Hi, this is lesson 1.7, Exploring Operations with Functions. So we're going to be looking at some functions and some operations with those functions. So we're going to be looking at f plus g of x, and that equals f of x plus g of x, f minus g of x, which equals f of x minus g of x, and f times g of x, which is f of x times g of x. Now, when we do each of those operations, what we want to do is for each one of those, we're going to be adding the y values. Okay, so just the y values are going to be added, subtracted, or multiplied in each of those cases. And from that, we have to make sure that we only add the y values that relate to the x values, or the values of the independent variable, on the common domain. This is the most important part. So the x values, or the x coordinates of the points whose y values we are adding or subtracting or multiplying, have to be the same. Okay, so let's see how this is going to work. So look down to the grid here, and what we're going to do is we're going to graph f of x equals 2x plus 1, where x is an element of all real numbers, and we're going to graph g of x is x squared minus 4, where x is an element of all real numbers on this grid here. So once we graph these, then what we're going to do is we want to graph f of x plus g of x and f of x minus g of x. Okay, so go ahead and graph those, please, and I'll show you what the graphs look like. So pause the video, please, and graph that. Okay, so this is basically the graph, and it's a little too big to see the whole thing. However, we can see the most interesting parts of it. So the parabola is x squared minus 4, that's g of x, and the line is f of x equals 2x plus 1. Okay? And now, so the best thing to do when adding these things, or subtracting and multiplying, is, and at this stage we're just going to be adding and subtracting, we're going to be adding f of x plus g of x, and then subtracting f of x minus g of x. So first things first, when I talked about before the common domain, the x values have to be the same before we can add or subtract the y values, or the y coordinates. So what I'm going to do is I'm going to draw like a little dotted line here, a dashed line, so that we can line up the appropriate points. Okay, so here's a point right there, and we have another point right here. Okay, we're going to be adding those y values because they share the same x coordinate. We're also going to be adding and subtracting these y values, or these y coordinates of these points, because they also share the same x coordinate. Same thing here. Here, these 2 points. And on it shall go. Now, even though the domain, the official domain of these is x an element of all real numbers, we've only got a small little snapshot here of these two functions right around the origin. So we can't really continue and do a whole lot more besides up to here. We can't add or subtract more y values than are actually shown on the graph. Okay? So now that we have all these pairs of points, we can now add and subtract the y values of those corresponding points, the ones that share the same x values or are on the common domain, and then we can graph those. Okay, so on the grid that was on the first sheet, or even if you have a little sticky note or other graph paper, you can graph it on your own. Add f of x plus g of x And the other thing that's very important when you're subtracting, make sure that you have it in the right order, because it makes a big difference. Subtract f of x minus g of x. Okay, so pause the video, and after locating these y values, the y coordinates, add or subtract those y coordinates to form the new graphs. Okay, so here's what f plus g of x and f minus g of x look like. Okay, so f of x plus g of x is again a parabola, and notice that the vertex has been shifted over to the left one. Actually, the whole parabola has been shifted over to the left one. That's from the influence of the line 2x plus 1. And because we did f of x minus g of x, that would flip the parabola, x squared minus 4, and it also moves the vertex over to the right one, moves the whole parabola over to the right one. So those are the two graphs for f plus g and f minus g. Okay, so take a look at those. Make sure that the graph that you graphed, or you sketched when you pause the video, match these graphs. Okay, so let's move along now. We have a table of values here. And this table of values is for those same two functions, f of x and g of x, on the domain from -3 to 2. Okay, so we have all the x values. We've got the f of x values and the g of x values. Now what I'd like you to do is fill in the f plus g values from this, so from these results here. Add f plus g for these, subtract f minus g, then please subtract g minus f, and then multiply f times g. Once you have those, can you please verify on the graph that you graphed previously that the points of f plus g and f minus g are the same as what you had graphed before? Okay, so the finished table looks like this. And here are the graphs for g times f and g minus f. Here are the graphs that I'll show you for these. So g times f actually ends up being a cubic. And so you can pick out some of one of the turning points here at roughly, it's about -1.5 and say 3 3/4 more or less. This turning point here is at 1 and -9, and the y-axis, sorry, the y-intercept is at 0, -4. Okay, so that's g times f, and then g minus f. Notice how f minus g was, the parabola was inverted, it was opening down. In g minus f, the parabola is opening up still, and the vertex is at 1, -6. And then two zeros are at, what's that, 1, 2, 3, about 3.5, and -1.5 roughly. Okay, so just verify that those are the same as your graphs.